Look at the rest of our U substitution today, and just to refresh ourselves as far as kind of a procedure, we had done a couple of examples, relating what we had done before with a function composed with a linear function, and why that all happens, and we kind of tied that to our U substitution. And with our U substitution, remember, we are looking for some function inside another function, and then if we can rewrite that as U, and we can also figure out what du is, we can substitute that in, find the integral, and then substitute the original function back. Okay? So, that's what we're looking to do here today. I want to run through another example and kind of go through kind of a step-by-step procedure. I know some are a little more analytical, so it's helpful to have that procedure here. First thing that we want to do is recognize a function within what you're trying to integrate. In other words, identify what u is. Okay? In this case, we have the integral from 2 to 5 of square root of something, yeah. And u is going to be that x plus 3. Okay? Now, what is the derivative of u? Well, derivative of u with respect to x is what? Come on. What's the derivative of u with respect to x? 1. Okay. So if I want du by itself, this means du equals 1 times dx. Okay?
Gotcha.
So this is kind of nice because now...
Do you equals dx or do you times dx?
Well, I multiplied both sides by dx to get rid of it over here and get du by itself. So I got to do the same thing over here. So it's 1 times dx.
Oh, okay.
Okay? So when we're doing the substitution here, I can substitute u in for the x plus 3. It's the integral of u. And then notice I already have a 1 dx here. So I can replace 1 dx with du. Okay? So now I'm taking the integral of the square root of u du. Okay? So notice here, number 1, recognize what u is. Number 2, get the rest of what's in the integral equal to the derivative of that function. That g prime of x du, or, alright, what we have over here. Now, you'll notice at this point, I'm not going to bother writing the 2 and 5 here, alright? This is just to protect myself from making a mistake, okay? What are we substituting 2 and 5 in for, eventually?
I don't understand the question.
Definite integral. Once we integrate, we substitute the 2 and the 5 in for
Area?
we're finding the area, but once we know what the antiderivative is, we plug in 2 for what variable?
Y.
X. Okay? X.
Okay.
It's 2. It's with respect to x, and we've got x's here, right? So here's a common mistake that people will make, all right? We're doing, we've rewritten the integral, step 3, as the integral of u to u. We're going to integrate it as usual, so the integral of u to the 1/2 is now u to the 3/2 times 2/3, right? Okay? But you can't evaluate, you can't do the fundamental theorem of calculus here Well, you've got u in there.
So you
Because u doesn't equal 5, u doesn't equal 2, x equals 5 and 2. So this is where, right here, we're going to substitute x plus 3 back in. So I have 2 times x plus 3 to the 3 halves all over 3, and that is what I'm going to evaluate from 2 to 5. Okay? So after you plug it back in, all right? After you plug it back in, then you can evaluate using your fundamental theorem of calculus. All right? So I'm going to have 2 times 5 plus 3 to the 3 halves over 3 minus 2 times 2 plus 3 to the 3 halves over 3. Okay? You figure out what all that equals. We get 2 times 8 to the 3 halves. That's going to be cubed and then square rooted. Okay? The square root of 8 is 2 root 2. Alright, so 2 root 2, we still need to cube that. Over 3 minus 2 times the square root of 5, but we still need to cube that. Alright, so let's see, this is going to give us 2 times 8 times the square root of 8. Alright, so that's going to be 2 times 8 times 2 root 2. So that's 32 root 2 over 3 minus, that's going to be a 5 root 5. So now we have minus 10 root 5 over 3. And you can just leave your answer in terms of the radical here. Okay? Or if you really want to punch it into the calculator and get one decimal answer, you can. Okay. All right, any questions about what we did here? Just to run through the steps again, identify u, find out what du is, and get the rest of the integral here. You know, in this case, we didn't really have to do anything. We just had to identify the fact that we already had du. That allowed us to actually do the substitution and rewrite it. Then we could integrate, and before we used the fundamental theorem of calculus, we substituted back in for u. Okay? All right, so I want to use, let's see, we did this one yesterday. Let's take a look at this one and kind of go through the steps here. All right? Now, when you're looking at these, identifying u is going to be the challenge. Okay? What's the u in this case?
The bottom. What's inside the radical?
What's inside the radical? Okay? That x cubed plus 5. All right? So we've got the x cubed plus 5. Now, du dx equals what?
3x squared.
Yeah. Well, we haven't forgotten how to do derivatives, have we?
Not yet.
All right, not yet. Hopefully not for a long time. All right, so here's du dx. So du has to be 3x squared dx. Okay? Now, here's where rewriting this is going to be a little helpful, all right? I have the integral of, I'm going to look at just this denominator first. It's going to be the x cubed plus 5 to the negative 1/2 power. All right, it's in the denominator, so it's negative. It's in the square root, so it's a 1/2. Okay, and then that's times x squared dx.
Would you multiply 3 inside and 1/3 on the outside?
Exactly. Yes. I'm going to multiply by a 3 on the inside and a 1/3 on the outside. So I'm just multiplying by 1 here. Okay? And notice here, now du is the 3x squared dx. Okay? So here's the u substitution. I've got the 1/3 here, integral. This inside the parentheses is u, so it's u to the negative 1/2. And then this whole thing I'm replacing with du. Okay? Now that looks a whole lot easier to integrate than this up here does. Okay? That's what makes u substitution so helpful. We can take things like this, and a lot of times we are able to, figure out a way to substitute in this du. Now we're just integrating something to the negative 1/2 power. So it's now something to the positive 1/2 power times 2, right? So times 2 over 1. Okay. We do have the plus c, but for our final answer, we need to make sure we don't leave a u here. Okay?
Is it divided by 1?
Well, remember it's times the reciprocal of the new exponent.
Oh.
So times 2 over 1. I was just putting the 1 so you could see the exponent, the reciprocal of the exponent. Alright, so our u was an x cubed plus 5. That's square root. Okay, and then we have a 2, and it's over 3. Okay.
Plus c.
Yeah. Plus c.
Will we ever lose point if we don't put a plus c?
If you're asked for an indefinite integral, yeah.
Oh wow.
Would it be the accuracy point?
I think so, yeah. Okay. All right, so I want to try some here. Okay. Oh, where did that went backwards? Okay. Let's real quickly walk through these. And notice it helps us by identifying what u is for us. Okay? So real quickly here, let's identify du for each of these, and then I'm going to let you guys do the rest on your own. Okay? So, du, what do we get for part A here?
3x squared dx.
Yeah, 3x squared dx. Okay? Alright, so how about part B here? If this is u, what's du?
3x
Squared.
3x squared
dx.
dx, okay? Du dx is 3x squared, so just a du is 3x squared dx. Okay? And now u prime of x, or if u of x is sine of x, du is,
Cosine of x dx.
there we go, cosine x dx.
Question. On that first one, when
substituting in the u, can you take out a 3 outside the integral? Or you can't because it's not for both of them?
Wait, on the first one, when you're substituting in for
Like,
u?
When you substitute u, right, you have, don't you still have 3x squared times u to the 4th du, or is that 3x squared du?
Well, here, for part A here, we would rearrange it so it's x cubed plus 1 to the 4th times 3x squared dx. And then that's where
That's your du.
this one is set up nicely for us. That is du. Okay?
So then it's just u times, u to the 4th times du.
It's u to the 4th
Oh.
du. So we're integrating u to the 4th du. Substitute it back in. Okay? So what's the integral of u to the 4th?
U to the 5th over 5.
U to the 5th over 5. So that means our final answer for this one would be
x to the 3rd plus 1 to the 5th over 5 plus c.
very good. Okay? Okay? Alright, I'm going to let you guys finish the rest of these here. Okay? Try these next two, finishing those on your own. Okay?
Can I ask you my question now?
Mr. Nixon, are you pausing the recording? Or are you not recording?
I can't really pause it.
Oh, then go for
But-
it.
Yeah, it's so cool.
You listen to it, you'll know which one it is.
This, I have no understanding of how to do it at all. How is my attempt? And then,
You need to use the rectangle, so you need to make this x, these x, and these y,
okay,
alright?
so these x and these y, okay, so x, so yeah, that's what I, no, that's not
Your-
what I-
Your cos,
Mhm.
you know your cos per meter, it's 11. So
Eleven
this side is
for
gonna-
x and 3 for y.
Yeah, so, well, 11 for this x, only 3 for this x.
Oh yeah,
So
that's
your
right.
total cost would be 11x plus 3x plus 3y plus 3y.
That's it.
What to do with the?
But here's the
So
thing, you need it to
you
be all
have-
equals one variable, and that's where
u
the
is
area
x
comes in.
to the 3rd
Plus
plus 1,
25
which is the
equals
exponent
xy.
of.
Just do the.
In order to get the 3x squared, you just have to multiply 3 inside
over
and
Uh-huh.
1
And then substitute that into the cost you just got. That's how you get your function. Then it's just get the derivative equal to 0 and figure out your min.
Okay. And on this one, now I know why I didn't get it.
Don't
This
do
one.
that.
So this, I just,
Because when you
for,
have-
I don't
okay,
understand
listen.
this question. I just plug in the x into what I find here, which is gonna
Yeah.
be 2
Oh,
sides.
And I put pi into
They're
this.
confused,
Yeah.
guys.
But you needed to use the
Yeah.
product.
The thing, yes. UV,
U prime b
U
plus u
prime,
v prime.
yes, yes, okay, okay.
I am.
I'm almost on front.
I know, that's okay.
Yeah. Submit.
Oh, no, no,
So
there's
I
one more.
got, this far,
When you do the second one, it's gonna
so I mean, like, when you multiply by 3, that means multiply
What else am I supposed
to make, you multiply d to the whatever times the derivative of
What?
1/3.
No, I'm saying how you would find the answer.
Yes.
I just don't know, it's easier to do, it's e to whatever, so
Oh,
then it's like.
what's the integral of e to a power?
They're just the derivative and derivative.
So it's just
e to whatever.
1/3
So
e
if you
to
just say
u.
e to whatever.
And then you can plug
So
back
it's e to
in.
u?
So 1/3 e to the u.
No, just 1/3 e to the u power.
That's it?
I think I have it there, it's 1/3 e to u to u.
Yes. Yes. All right, let's look through B, okay? Let's work through B. A number of you are getting this here, okay? We have the integral of e to the x cubed plus 1 times x squared dx. And I rewrote it here because we need a 3x squared dx to get our du. All right, so I'm going to throw a 3 in here and a 1/3 out here. Okay? So there's the du, and now I have the integral of e to the u du, that's times the 1/3. Okay? What's the integral of e to the u?
EU.
E to the u. Okay? So that's just e to the u. Alright? So now we'll substitute back in the u. Okay? We have e to the x cubed plus 1 over 3 plus c. Okay? Not that right now.
Oh,
Okay.
I don't get how you put the 3 back in. Like, oh, okay.
Well, the 1/3
Yeah.
is just there. We put the 3 here so that it matched du. So we could
Oh.
substitute du in. But if we're putting the 3 there, we got to put the 1/3 outside. Okay? Alright, this third one, let me rewrite it here.
We have another minute to try it.
Sure.
Physics?
Let's see what they do.
I don't know physics.
Alright, so we identified du to be the cosine of x dx. So this right here is du. Sine is u, so we have the integral of u to the 4th du.
So
Right.
it's just like the original one, right?
It's just like the previous one that we had done here. Yeah, right up here. We just have a different u in this case. Alright? So we got u to the 5th over 5. But now when we substitute u back in, u was sine, so it's sine to the 5th x over 5 plus c. Okay? So here you see the similarity between a and c. We had the same kind of outer function, something to the 4th power. Alright? And in a and b we had the same inner function, so we were looking for the same du. Okay? Alright, one last one here. What's our inner function? What's the u?
X squared plus 3x before.
X squared plus 3x. Okay?
So you're gonna use the chain rule with the u?
Well, let's think about this. What is du in this case?
2x plus
2x.
2x plus 3 dx, right? So, the 2x plus 3 dx is right here. So that is du. So now we have the integral of u to the 4th du. And now we're back to a and c on the one we just looked at. U to the 5th over 5. Since u is x squared plus 3x, it's x squared plus 3x to the 5th over 5 plus c. Okay? All right. So, I've given a little bit of practice. Hang on, we did this already. We did that already. Okay. Here's another one similar. Okay. Again, if you've got multiple things here and one of them's raised to a power, that can help you figure out what u is. U is going to be the thing that's raised to the power, most likely. 2x cubed minus 3x squared plus 1. The derivative, 6x squared minus 6x dx. Okay?
When is there a case where that's not?
Oh, I get it now. There you go.
Okay.
Got it.
So now, what do we have to do with this one?
We multiply 6 into it.
Okay,
6 out of it.
Just
yeah, if we
factor
factored a 6 out, x squared minus x, then we would see, hey, we actually have most of this already. So I just need to throw a 6 in here and a 1/6 out here. And we got it, okay? And then you're integrating 1/6 times the integral of u to the third du. Okay?
Yeah, have a good trip.
See ya.
See you. Lunch.
Alright.
Happy birthday, mate.
Thanks, Jose. Put it in.
Thanks a lot. I'm a
Alright. So we have 1/6 u to the 4th over 4. So now we put u back in. 2x cubed minus 3x squared plus 1 to the 4th. That's over a 24 plus c. Okay? And that's it. Okay?
Okay.
That's our u substitution. It's got to kind of be set up for you. Alright, but it's not terribly uncommon. Anything that we couldn't do this with, we would have to use some method like the trapezoid method or something with those sums that we looked at right at the beginning of the integrals. Okay? So,